Cool. Hello, welcome everyone to the second lecture of the database programming in practice course. In this lecture, we're going to talk about data persistence. Actually, this lecture was like one of the lecture that I pulled out from the programming course last semester, and I put it here instead because it's also I uh I believe that it is more relevant to this course rather than in the programming. Okay, so that's why I moved this lecture to be in this semester instead. For the administrative stuff, I mean, in lecture one, I told you that there will be 4 solo projects, and the first solo project will be released today. Actually, I released it already. You can check it out on BigGrade and also on the course website. It's due on December 16th, which around 3 weeks, less than 3 weeks from now. Okay. And for solo project, we still need to do checkout. The checkout will be less strict than last year. Oh, sorry, last semester. So, but you still need to do some practice. Also, sorry, I would suggest you to do some practice before getting to the checkout. Okay, so the checkout will happen during December 15th to 19th, so the whole week from Monday to Friday. So Monday 15, Tuesday 16, Thursday 7, sorry, Monday 15 December, Monday 15, Tuesday 16, and Wednesday 17, I'm on the plane. So if you are checked out during that time, you're going to be checked out with our TA. But for December 18 and 19, I'm on site right now. I'm in Thailand right now. So in case that you would like to check out with me, I don't think you want to, you can do the checkout with me on December 18 and 19. Okay. The warning is that even though I give you almost 3 weeks, start early. You can ask, I believe that you can ask your senior student what's going on with the first assignment that I gave to them last year. It's what chaotic, It's it is there will be a difficulty gaps from last semester. When you check out the project, you will see that it will be a lot more difficult than what we had last semester. So that is why I give you like more than 1 week. And also I suggest you to start early. Okay. If you don't understand anything about the projects, ask us on forum, right? We are very willing to help you out. Okay. Any questions? Okay. Hope everything is good. All right. So just to recap what in lecture one, in which I believe that all of you have already watched the video, data basic. So this course is database programming in practice. The word database that we talk about in lecture one composed of 2 words, right? Data and database, data and base. So data, the first word of the word database are basically facts or informations. Um, and one of the benefit of these facts or information is to use them to make more accurate decisions, right? When we compose the word data with base together, we got the word database. Database means the organized collections of data. So it's not just a facts or information scattered around. It's more like we're trying to make them organized in a certain way so that it is easy to use. Or it is like, yeah, it is easy to use. Yeah. And one thing that I believe that all of you can sense it is that, especially in the AI era, right? That when we have more data, the results or the decision making will gonna be more accurate, right? I think the one of the very clear example is AI. LLM, large language models that we are using nowadays, they can be those accurate because of the amount of data that they use to train those models. Right? Well, not think, let's say not talking about AI. Let's say we talk about um weather forecasting. In Thailand, the weather forecast may not be that accurate, especially when you compare it with like in the States, like me, where I'm saying right now, that this is much more accurate because there are a lot of data points that we use to do the weather forecast, you know, right? So with more data, you're typically gonna be capable for like a more accurate decision making, you know. But in order to get a good amount of data, you need to have the way to collect it, right? You need to have the way to collect the data, gather the data, and then keep those data, store those data somewhere. So this leads to our motivation for this lectures. So imagine that you would like to store data. Nowadays, people, okay, one other way to store data is you maybe note it on a book, right? Physically, right? You have a paper and then you write down data on the paper, right? But I doubt no one's, I doubt people do it. Nowadays we are in the digital era, and especially with the smartphone eras, right? So we just use mobile phones and generate data. You put some data, you're posting something, you're like recording some videos and post it on um TikTok, YouTube, Instagram Reels, right? So those kind of things are what we are doing right now. And then those applications gonna collect your data, right? Gonna collect your data, gather your data, and then keep it somewhere. They're gonna keep your data. Instagram, YouTube, what the hell is this? Oh, Google Drive, and we have Canva, right? So all of these applications, all of these programs, they collect data from you, and then they're gonna keep it, right? Okay, so these are like the programs nowadays. But based on what you have learned last week, last semester, right? In the last semester, if you want to keep the data, let's say you want to write the receipt program, right? Our good old receipt program that we try to store a list of items, right? Well, when you store a list of items, you put an item into a list. Those items, those data, those information will be stored in what we call memories, right? Memory is one of the hardware device in your computers that it used to temporarily store program data, or the data that used by the programs. Okay. The problem about storing data in the memory is that, well, it's not a problem about the device, but it's more like the problem of the way your computer works. So normally, when your program ends, those data in the memories will expect to be removed by your computer, to be more precise, by your operating systems. Okay, so basically, once the program ends, you won't be able to keep your data alive anymore. The item that you put onto the receipt will not exist anymore. And one way to say is that, let's say, imagine that these Instagram, YouTube, and those applications, when you close, when you close your applications and then your data gone, that is unacceptable, right? Because some of the data are very important. So I think one of the good example is this Google Drive. Sometimes we store very important information or data onto Google Drive, right? So let's say if you write a program in the good old way that you just like put your informations into the memories. And then once the program ends, it could be end by an accident, or it could be end by like someone intentions. But eventually, if it's end, then your data gone. Your data just gone. You know, if that, let's say if that data is very important, that is unacceptable. Let me give you more like realistics and also a very serious events, right? So there was like a back in not that too long, right? There is like a news saying that South Korean government learns it needs a backup the hard way because it like some of the data center, if I remember correctly, get destroyed by fires, right? And it lost like 850 terabytes of data. Imagine you lost this amount of data. I doubt that these data gonna contain some of them gonna be like some very critical informations, very important information as well. So that is very sad, right? Also, this one, 2015, Google, Google lost data. So if we just say this, Google launched Google Drive, right? You store information on Google Drive. If let's say you put on like a very important files on Google Drive, and then next day you accidentally cannot find this file anymore, and Google said, "Oh, I just got lightning hit, and this part of data are gone." Well, if I were you, I would be very frustrated, especially if that data is very important. You see where I'm coming from, right? So what I want to say is data laws are very unacceptable in many cases, in most of the cases around the world. And if we still keep the data, if you still write a program to keep the data in the old way in the memories, we won't be able to store important data anymore, right? So we need to have a new way to store data and keep it alive for a long time. So today in today's topics, we get to talk about data in memories, data persistence, file system, file IO API, and the Solar Project 1 will be related to the topic that I just introduced to you. Okay, any questions so far? Any questions, comment, concerns before we moving on? No, I doubt it. I believe that you are still sleepy right now. Well, again, if you do have questions, comment, concerns, feel free to just type your text on the chat, type your question on the chat, or open up the microphone. That's how the way this class works, right? So I can immediately respond to you. Right? Let's talk about the first part, data and memories. So I talk about that data and memories. Like data and memories does they do not have like a very long lifespan. So let's see it in action. Why? So let's say I write this programs. Okay, look into this program. Do you still understand what is this program? Based on your knowledge from the previous semester, do you still understand what this program do? If you still understand, can you maybe hit some thumbs up? If you don't understand, maybe hit some thumbs out things. I don't see anything. Anyone put on some emojis? Do you understand what it is right now? Like, what is this code? What does this code do? Yes or no? Well, I believe that most of you understand. If some of you don't understand, make sure that you understand it as quickly as possible, right? Because in this class, we are mostly going to assume that you have at least a good level of a solid programming skills. Okay, so basically, this code, right? We have a list, an empty list, and uh, where the variable records we used to reference this list, right? And then we have a while loop, or basically an infinite loop. And inside the loop, we try to get an input, a string input, right? And we put into the variable record, and then we append the the list correct records with a strings that we get from the input, right? And then we print out the list records, and then we loop through it infinitely. So this program basically not gonna be end, right? If you run like forever. So let's see. I'm saying that these program data gonna be kept in memories. So this is actually a diagram of what's gonna happen inside of your computers. So it will be a little bit complicated, but I will try to explain it so that you will kind of like understand it as much as possible. So the program start with this, right? Records. So when we hit this record, so this part is main memories, right? The memories are basically your RAM, your RAM. Okay, so once we hit this line of code, in the memories, you put the empty list in the memories. So now in the memories, you have an empty list. Okay, and then we do the loop. We continue doing the work inside the loop. So in this line, you're taking an input, right, from the keyboard, right? And then this is input. This is input here. Input here, right? This input will be taken from the keyboard, right? And then you put the input here taken from the keyboard, put into the record variables. So that's why we have a list, an empty list for records and a string for record that you just type in. Then you append the record into records, a list here, right? So before you have an empty list and a record, right? A string record. And then you put record into a list. So now you have a list of the first string input, right? And then you print it out. So the printed out is we're gonna copy the thing in the memories, right? And put it onto the display of basically your monitors, to display the list. So this is the typical program loops. So let's say if the program keeps going, right? We take the new records, we append record to the records here, and then we print it out. We're gonna get into the loop here. But it can also be possible that somehow program may be crashed, or maybe you intentionally close the programs, right? Alternate F4, or if you still remember from last semester, you can hit like Control C in order to access the Python programs, right? Or maybe your computer gets shut down for some reason, right? Maybe the power is gone, something like that. So if this happens, your data in the memory will soon be replaced by something else. In which means that all the records here will be soon gone. Right? Or basically when programs in data gone, right? Well, just a note that in a very hacky way, you may be able to access them in a very hacky way. But even though we have a hacky way, it is not guaranteed that we can always do it. The question is, okay, if you want the data to keep alive, why don't you just run the program forever? And we just run a program for like days, like what we do with the receipt, right? We just build a long running program and we run it for days, for months, for years. Why? Why don't we just do that? We still have another constraint, right? Let's say if your computer, your power is gone, data is going to be gone. Why? This is basically because of the main memories here. The main memory here. Main memory here is basically a device that we call a volatile device. Volatile device means that that device requires electricity in order to work, for it to work, without electricity, those devices cannot keep any information alive, right? So that is why when the power is gone, maybe you turn off your computers, those data are going to be gone as well. The questions that I want to pose to you is that, so, okay, we close the programs and then the data is gone, right? So why don't we just run it forever, right? And I say that, oh, the power is off, data is going to be gone as well. So why don't we just run the computer forever? And then we run the programs forever as well. Why? Why is this not possible? Well, I'm not going to say that this is not impossible, but in real world, there are going to be some unexpected problems happen. For example, Yahoo California data centers get taken down by a squirrel. So squirrel basically make a war data center down And data is they're basically computers storing information. Let's say the data centers store information in memories, and then this tiny squirrel taken down, took down the data centers. All those data are gone. Is this acceptable for you? Likely no, right? So we have these kind of unexpected issues happens, right? Um, well, this may be like not this may be unlikely in Thailand because we don't have much squirrel, right? But in Thailand we have rainy season, and rainy season equal to power outage. Right? I mean, that is normal in Thailand. Which is sad, you know. We also have like some natural disasters. For example, the I think the most relatable one's gonna be like the flooding in the southern part of Thailand right now. You can see that it caused a lot of power outage as well, right? Um, yeah, these kind of things are the events we don't want it to be happens, and they are unexpected most of the time. So to answer this question, that why don't we just run the computer forever? If you are lucky enough, in which you are unlikely to be that lucky, then given those unexpected events, it is very hard to run the computer forever, and you don't want to run it because it's gonna deplete your power as well, right? So once the end of the month, you get the power bills, you get the electricity bills, and you say, "Oh my God, holy God, why it's so expensive?" You don't want to run the computer forever, right? So that is why today topics is about data persistence. Persistence means that we would like to persist the data so that the data is still alive after your power is off. The idea is that, okay, memory devices like the RAM on your machines, they are volatile, right? Volatile means they need electricities. Why don't we just store informations in the devices, in the on the devices that doesn't require electricities? And that's our solution. So normally on your computers, you have two class of devices that can be used to store data. The first one is your RAM or memories, which is this one, right? Which is what I just have told you before, right? The second one is a disk like this. A disk like this is like a device that you can store data without the need of electricities. So even though it doesn't have electricities, the data will still be alive on this kind of devices. You know, well, just a huge remark that even though I said that data can be alive without electricities, but these devices have like some lifespan as well. For this, you can keep the data alive for like I think 10 years before before the device get bad, you know. For there is a new type of disk that people now they will use it, which is the SSD, like solid state drive. Solid state drive mean a disk drive that it doesn't uh it use uh it use electrical cells to keep data alive. But it doesn't need but you don't need to plug it with like you don't need to plug it you don't need a power like all the times, you know. It has a mechanism so that it can keep those electricity alive on the device, right? So those solid state drive, sadly, the lifespan are less than these hard disk drives. You know, it's like around 5 to 8 years, something like that, along that line. Okay. No, but what I want to say is, if storing on in memories, the data is gonna be gone, then we're gonna store on this instead, on this device instead. Yeah, and well, it's not 100% durable. it's 100% that the data on the disk will be always alive. It have certain lifespan. The disk can be corrupted as well. So this is what you need to put it on your mind. Okay. So yeah, two classes of the devices: memory or volatile, which require electricities, and the disk, which is non-volatile, which do not require electricities. Okay. Any questions? Do you still understand? You still understand, right? Good. Okay. So the question is, why do we need to have many of them? I mean, for memory and disk, that is, well, still, why don't we just only have this? Why do we need to have memories, right? Why don't we just, okay, so if we keep things in memories and it's gonna be gone, why don't we just like only disk? We only have the hard disk drive, and when and everything, and the program data, we store the program data on this. Why don't we just do that? Also, you see, the memories, we have two types of memories, at least two types of memories: SRAM, the static RAM, and the dynamic RAM. Why do we have these many memories devices? For this, why do we need to have solid state drive and hard disk drive? Why? Let me ask you guys, for someone who are familiar with uh, computer hardware, right? So let's say, I believe that most of the computers right now are using solid state drive. But back then, maybe like 5, 10 years ago, we still use hard disk drive. Let's say if you are going to buy a computers, one computers use hard disk drive, another computer use solid state drive. Which one are you going to buy? The hard disk drive, the one with solid state drive, the one with hard disk drive. Which one? People in the room, we can also answer as well, right? So we have two computers, right? One with solid state drive, one with hard disk drive. Which one are you going to buy? Are you going to buy the one with hard disk drive or the solid state drive? So for me, I suspect that many of you going to go for the solid state drive. And the quick and easy reason is that solid state drive is faster, right? It is faster. And that is one of the reasons why we need to have two types of storage devices. Why your computers do not only have, why your computer doesn't only have this, but it also have memory as well. That is because two reasons: performance or the speed and the cost. Hard disk drive are cheaper. Hard disk drives are cheaper than the solid state drives. Why solid state drive is faster? Is faster than hard disk drive. So that is why nowadays, if possible, we're gonna go for solid state drives because they are faster. They make your computer faster. This goes the same between flash storage or the solid state drive versus dynamic RAM. Dynamic RAM are much faster than flash storage or the solid state drive. You can see the latency here is basically the time when you want to read data. If you go for flash, you use 100 microseconds. Looks it's very fast, right? But if you use DRAM, you can go like more than 10 times faster. That is why when your computer is trying to run a program, they tend to store your program data on the memory devices because they are faster. They are a lot faster. So it is very easy to read the data from the memory in order to do the process, in order to do arithmetic operations, in order to do if else, in order to do the loop, right? If your program data is on the disk, your program is gonna take like it will be like 10 times slower. And in many cases, that is not good, right? Imagine you play a game. You play a game with like 120 FPS. That is that is amazing, right? That is good. You know, the video looks a lot better, right? But let's say if your video games is running at 12 FPS, 12 frames per second, on your videos are running at 12 frames per second. For most of the videos, it will be very lacking, and you're not gonna be, and you're not gonna be, and you're not gonna enjoy it, right? So that's why they're trying to have like memory as well, so that once in order to make in order to put the program data onto it, so that we can read the program data faster than we need to gather from the disk. But we still need the disk because we would like to have some data that can still stay alive can still stay alive after the program ends or after your power of the computers get off, right? So that is why at least we need to have memories and disk. Okay. Mostly SRAM or static RAM is the fastest one, right? The hard disk here, mostly the slowest one. We also have like a slower devices called magnetic tapes, in which I believe that people nowadays we don't use it anymore. You can ask your families, your mothers or your fathers. I believe that they may have experienced them. Magnetic tapes. Those are very slow, but they are also very cheap as well, right? But the problem of the tape is that they are unreliable. You can lose data very easy, you know. So today, what's going on with the computer is that they're trying to make you buy a large disk. Maybe right now your disk on computer is like 1 TB, right? 2 TB or something like that, or maybe 512 GB, right? But for RAM, you're not gonna have 512 GB of RAM or 1 TB of RAM. You're not gonna have that unless you are very rich, you know. Normally, your computer gonna have like 16 GB of RAM, right? 8 GB of RAM, 16, 32 GB of RAM, right? If you have 64 GB RAM, that's awesome, right? But you're not gonna have the same size as your disk. That is because RAM is a lot more expensive than the disk, and not all computer data or not all program data are being used at the same time. Which means you don't need a very large RAM. You just need a RAM that you can fit in the program data that you are currently used at that moment and put it on the RAM. Right? So that is the only thing that you need to put on the RAM. And once you're done with those data, you can keep those data back on the disk that are cheaper. Right? So the point is that mostly people want to store frequency use data in the faster memory like RAM. Or if you have like both SRAM and DRAM on the same machines, mostly you're going to store the frequently used data on the SRAM. A little bit less frequency used data on DRAM, and a less used data, non-frequently used data on disk, something like that. So you can see that we form something that we call a hierarchy, right? Um, if I'm gonna draw pictures, I'm sorry for my bad handwriting. Again, I didn't connect with my iPad. I do not connect with my iPad, so I'll try my best. So basically, you have SRAM. So this is SRAM. Okay, you have a little bit larger DRAM, and then you have a huge disk. right? Some programs they are very large. For example, the video games. Some of the video game nowadays they are like 200 gigabytes, 300 gigabytes, right? 200, 300 gigabytes. Okay, nowadays we can store them on disk easily, right? So let's say I saw the whole program the whole programs on this, right? But at some moment, you only need to use some part of the program, only some part of the program, and you can put this part of the program onto the DRAM, which is faster, right? So that your computers can access this data a lot faster. You don't need to crawl back into all the disk, right? And then since we have another level that is more fast, that is faster, then given this data, you can put more frequently used data, much frequently used data into this SRAM. And then every time you use this very frequently used data, it will be very fast. You can access it very, very fast, a lot faster. So that is why we call this a memory hierarchy. I love to call it a storage hierarchy because, okay, the first two are memories, but the last one is not that kind of memory anymore, right? Okay, you got this idea? So this is like where most of your computers have this. Most of your computer doesn't have only, do not have only like one storage device. They have multiple storage devices, right? In most of your computers, you're gonna have like CPU to process your instructions, and then you're gonna have the first SRAM. We mostly call it L1 or level 1 cache. And then we have a larger cache called L2, level 2. We have a much larger cache called L3. So L1 and L2 are usually an SRAM. L3 are DRAM or SRAM in some machines. And then we have uh, a huge main memories. I call it MM. Right? And our memory, we have this mostly the solid state drive, right? But for this main memories, it's mostly gonna be DRAM, right? So normally your computer is gonna be something like this, right? Again, I'm sorry for my bad handwritings. Okay, let me erase it. You got it, right? Any questions on this? Okay, I don't see any question. If you have any question, feel free to put them on the chat. Okay. So yeah, that is why we form something that we call a hierarchies of memories, devices, or the storage devices like this. So register is here. Oh my God. Um, so register here is what in the CPU, right? The cache, well, even though it say on CPU, but some of the cache are not, well, mostly they are on CPU. Okay. The cache here are the L1, level 1, level 2, level 3 that I told you, right? The main memory here are the DRAM that I told you, okay? Flash disk, here's a SSD. Traditional disks are mostly like the hard disk drive, the magnetic disk, and we're gonna have like the remote secondary storage, which basically those Google Drive things or the cloud storage. That it is slow because it needs to go through internet, right? And the internet we don't have much bandwidth, right? We have limited bandwidth. So that is why it's the slowest one. It doesn't need to be the slowest one, it depends on the situations. But most of the time, it's gonna be the slowest one. Okay. The question is, can we learn all of those things? We learn that, oh, okay. Well, based on what I say, so far. Oh, basically, if I want to keep data, like I just need to write or read to or from the disk, right? Yes, you just need to do that. If you want to process data and make it alive across like power on off cycle, just need to be able to write something or read something from or to the from write to or read from disk. So let's see how do we do that? How do we do that on typical computers? On your typical computers, you have something that not computers on your typical operating systems, Mac OS, Windows, Linux, so on and so forth. They will have one subsystem. So they will have operating system, right, as a whole. And inside of the operating system, we're gonna have a lot of subsystems for doing like um duties, different duties. And one of the subsystem in the operating system is called file system. A file system is a subsystem that give you and give you like an interface. If you still remember what is interface, right? Give you give you a way so that users like us can interact with these devices, can interact with disk. So I use it with abstraction here. So it's like a layers. It's like some abstractions or something that we can use to interact through the interact with the disk through this abstraction, through these things. And this thing is the file system, right? File systems is the thing that allow you to see files on the disk, allow you to see directories on the disk. So if you don't know what the hell is file system, basically file system is just this one. It's just this kind of thing that allow you to see these files, right? The directories, allow you to see those directories. These are file systems. File system in most operating systems gonna be the fancy graphical user interface like this. But uh, for some operating systems, they could be just a programming interface. Programming interface is that for user interface like this graphical user interface, user can easily interact with it, right? But if it is a programming interface, it means that you need to write a program to interact with the file system, right? So far, so good, right? Any questions? I just got a message from one of the TA that uh there is a student who haven't registered for the course uh and they just registered. So you just register it and you cannot access to forum. Well, we already coded with Pipum, so Pipum should be able Pipum will uh add you to the forum, right? For the big grade, I will add you after this lectures. Okay? Right. Um well, as I told you in the lecture one, every lectures, rather than except for the lecture one, we're gonna have a quick quiz. All right. And it's not gonna be at the end of the lectures. I didn't say that. It can be pop up anyway during the lectures, like in this lecture. So I will give you 5 minutes, 5 minutes to complete the quiz. There will be 5 questions. I will send you a Google form, right? The next slide, on the next slide, I will show you a QR code. So right now, prepare your mobile phones, okay? Prepare your mobile phones. I will show you QR code. If you do not have QR code, if you do not have mobile phone for some reasons, I will also send a link on the Zoom as well. So there are two ways. There will be a QR code. So you can also prepare your mobile phone so that you can scan the QR, or you can also click on the link to do it. In the form, you need to log in with your email as well. Okay. I will give you 5 minutes to do it, including the login time. So there will be 5 questions. It will be just choices, multiple choices. So you don't need to type in text. You know, 5 questions, right? So let me ask you first whether you are ready for it or not. Are you ready? Well, I say to you already, right? Well, we're gonna have a quiz. So let me stop sharing, and then let me. I'm gonna pose a quiz. Well, I don't think you need to log in. I will just remove the login part. Uh, okay. So the QR will appear first, right? I'm going to share a screen. Okay, so let me put on the timer as well. So we use timer on my phone, okay? Timers, 5 minutes. Okay. So if you're ready, then three, two, one. So scan this, and then, or you can use a link on the meeting chat. And I will start a timer. So this is a timer. I'll start it now. Okay, so the timer starts now. Oh my God, you cannot see it. Oh my God. Yeah. So I start the timer now. You have 5 minutes to complete it. Don't forget to put on your student ID as well. Right. You have 3 minutes left. think about it carefully, most of the questions contain uh there could be multiple correct answers, and you need to answer all of them. Right? We have around 1 minute left. Well, by the way, I don't want you to worry that about the quiz that much because it's just 5% from like the total grades overall. So 30 seconds left. So once the timers stop, I will close the quiz immediately. So make sure that you hit the submit button. Okay. Only 15 seconds left. 15 seconds left. 10 seconds left. 9, 8, 7, 6, 5, 4, 3, 2, 1, and zeros. So I'm gonna close it now. Wow. Okay. All right. So let's see the question. Is it hard? Well, let's see the questions. Um, so can you see the screen? Okay. So the first questions just basically announce about the announcement, right? So Solo Project One's being rolled out, right? Select all the possible dates that you can do the checkout based on the announcement. So on the slides, I told you that it will be during December 15, 16, 17, 18, 19. So basically you need to check all of this, right? You need to check all of this. All of these are the correct answers because I asked you to select all the possible dates, right? But this is not technical. You just need to remember what I announced in the first few slides. Okay. The next one, Poom wrote a long-running Python program on his computers to keep his to-do list. He managed to keep his to-do list for a month, right? So it's very fortunate that he can keep this long-running programs alive for a month. But yesterday he lost all of his data. So what can be the possible reasons? The first one, Poom keeps his to-do list as a file. Is this a reason why he lost the data? Doesn't sound like a reason. Poom accidentally closed his computers. We talk about this that if the power of the computer is off, the data in the program is going to be gone. The data in the memory is going to be gone because memory requires electricities. Memory devices require electricities, which means this is one of the correct answers. Okay. Next one, the program used too much memories and crashed. For sure, right? We always saying that programs data is in the memories. And if it use too much memories and to use too much memory and the program crash, which means program ends, the data will be gone as well. Ning was talking to prove about the upcoming lab. This doesn't tell us anything. It's just Ning just talking. It's not the reason, right? It's not the reasons. So basically, the option number 2 and 3 must be answers. Right. The next one, based on the lecture, which of the following storage device classes is the cheapest? I say that based on the lectures. In realities, there might be a little bit different, but based on the lectures, we saying that the hard disk drive is the cheapest one. given all of these type of storage. But I would say that this depends on the capacity of the device as well. Let's say if you compare 5 terabytes hard disk drive versus 128 GB of flash storage. The flash storage could be cheaper as well, right? The next one, which of the following reasons are the reason why SRAM, even though it is one of the fastest storage device classes, has a very small capacity related to this on typical computers? We talk about it, right? So that it has a very small capacity because it is very expensive. Actually, there are 2 reasons. First, it is very expensive. Second, it is volatile, so we don't need to have a lot of them, right? So basically, the first answer is correct, right? It is expensive. The second one, it can do sequential access slower than disk. Well, we talk about it in the lecture that SRAM typically are faster than disk. Well, sequential access, this term, even though I haven't talked to you, you still should not answer this choice, right? Because it talk about access and the slower, the performance, right? Sequential access, I will talk about it in the next lectures or the next few lectures. Okay. Last one, most SRAM cannot store more than 32 integers. I mean, 32 integers is just like 4 times 32 are just like hundreds of bytes, in which most of the SRAM, they are like kilobytes. They are more than that, right? They are larger than that. So this should not be the answers. Okay. The last one, which of the following are not true about file system? File system can provide many user interface, whether GUI or programming interface, in which it is just on the previous slide. So this one is true, right? File system typically allow user to directly interact with this without going through any abstraction. This is totally not true because I told you explicitly that file system allow user to interact with this through an abstraction called file system or itself, right? File system used in common operating systems, Mac OS, Windows can manage only files. I just told you that files, directories are another one that it can manage, right? So this is not true. This is not true. The last one, the operating system cannot access without file systems. Cannot access without file systems. I haven't said that it cannot access without file system. I just say that one of the components in the operating system is a file system, but it depends on the operating system. Some operating system do not have file systems. So this is also not true, right? So that's for the quiz. You have any questions from the quiz? For the quiz, you have any questions, comment, concerns? I will adjust the score a little bit. I found that some of the choices are unclear, so I will try to adjust the score so that you get a little bit better scores. Okay. Yeah, but so this is the first time you got the quiz. So next week we're also gonna have a quiz. So let's be prepared. Okay. Right. And the quiz can pop like in any times. Could be during the lectures. Could be like in the middle of the lectures, before the lectures, at the end of the lecture. So you need to be prepared. Okay. It's a pop quiz. It's a surprise quiz. So let's get back to the lectures. So we're talking about that if you want to interact with this, you need to interact with file systems, right? Or basically, I'm telling you the data on this are abstracted as files or directories. So if you want to keep data on this, you need to save them as a file. Then one of the ways to use the programming interface, and you can use a programming interface, one of the ways through Python, to write a Python programs to interact with the file systems in order for you to store files, to store data as a files or on the files on the disk. Okay. For the basic rules, this is what you need to know before we get into the actual approach for Python. The basic rule is that every time you want to access files on disk, Every single time, you need to create something that we call a file descriptor first. In Python, basically, you need to create a file object, a file object, a file object. You create a file object, then you can access the files or the data on the files through this file object. Okay. And then once you're done with these files, it is a good manners to close this file object as well. I mean, for short running programs, not closing it is still doable because um, it's not that it doesn't matter that much. But for a long running programs that you're gonna open a lot of files, and if you don't close it, each file objects each file object's gonna take some space in the memories. So imagine that you run the program for months, and you keep open up files. This file, you kind of like aggregate this file objects into like uh tons of these objects, which is gonna take a lot of space on memories, and it could get your memory crash, right? So let's see in Python code. So again, I told you that whenever you want to access the file, access here, including creating a files, reading a files, writing a files, anything of any of those. You need to create a file object, and you can create a file object through the function called open. So you just need to put open, and then inside of it, it takes two arguments. The first argument is the path to the files. Next week, Indy will talk about different kind of path, right? So we have two ways to write a path. The first one is the absolute path. The second one is a relative path. The absolute path is that you need to specify the absolute path of the file to the files. You need to specify the full path, the full address to the file. The relative path is that you're gonna specify a path based on your current location, right? In which the Indeed will describe about this. Right? And then this is a first argument. So basically, it is a path to the files. The second argument is the mode of open, right? So once you specify both of these arguments, you created a file object. So you assign the values from the right hand side to the left hand side, which is a variable called file object, right? Then again, the second argument is what we call an open mode. We can have different open modes. The first one, if you specify R, it means that if you access the files through this file object, you can only read data from it. You cannot do other things. You only can read the data from it, from the file. We call it a read-only mode, right? The next one is the write, W, the write only. So you only can write the files. And the write only here means you are overwriting the files. It's not that you are like continue writing from the end of the files. You are overwriting the entire files. If you use W, but sometimes you say that, oh, I don't want to overwrite all the entire files. I only want to put on the back, at the back of the file, at the end of the files. I just want to add more data. So there are two ways. The first one is you may want to read the file first, copy all the all the contents of the files. Then now your copy of your file copies is on the memories, right? Then you can now write another files based on the old file content you copy and put it on the memories, and you write it on to the another files, and then you can put more things that you want after that. Okay. Another way is you can use the append only mode, which is A, right? If you put A, then you are allowed to put data right after the files. Sorry, right after the end of the files. Okay, you are extending the file. You are extending the files. And the last one, oh my God, if I want to read and write within a single files, how do I do it? So you can do R and plus. R and plus means that you do read only, but you also add a capabilities to write it as well. Right? This open mode, Indy will tell you in the lab next week. Okay. Indy haven't got his slides done, but yeah, I'm towing him through this Zoom. I'm telling him through this Zoom. Well, he's preparing the slides right now. Um, Okay, so again, as I told you, you can access the files through this file object. So given this file object, you can do anything. Read the files, write the files, so on and so forth. And then right after that, I told you that you should close the file object. For short running programs, it doesn't matter that much. But for a good manners, you should do it. For a very long running programs, you should do it. Otherwise, your programs could crash. Especially if you open up a lot of files. Okay? And that's it for the lectures. So, data, if you want to keep data alive, well, even though I say that's it, I didn't say that the lecture ends. I need to describe the Cello project number 1. So, believe, okay? So, in summaries, if you want to keep data alive after program ends or the computer power off, you must put the data as a file. That's it. That's the way. And to do it, you use the file system interface. You can use it through Python, right? Write a Python code to do it, or other programming languages as well. Okay, so that's all for the lectures. We spent like an hour for it. Any questions, comment, concerns? If there is a question, comment, concerns, let me describe you Solo Project 1. So, Solo Project 1, pretty similar to last year. So you can talk with your senior students, but actually the details of it will be different quite a lot, right? More than the half of it will be changed. So you will build a libraries, a data frame libraries. If you still remember in the last lectures, sorry, in the last semester, we talking about yeah, we are talking about pandas, right? That is like a way to store multi-dimensional arrays. So this time you'll be writing libraries by yourself. So the library is called Sunbears, right? Well, okay, I asked you to write a data frame libraries, but what the hell is data frame? Data frame is a table like data structures that you can access it in many ways. So basically, it provides you the way to create this table in Python. So if you're not familiar with this, I suggest you to go through videos like Pandas. Pandas is a very popular data frame libraries. So I would suggest you go through this. And well, I'm not going to teach you this year. I will teach you something new. And I expect it to be used a lot in the futures called polars. But Pandas should be maybe there's going to be a lot of tutorials on Pandas on the internet. So if you want to learn more about data frame, I suggest you looking into some Pandas tutorials. Okay. So Sunbear's going to have these methods pretty similar to the final exam, right? I so basically Sunbears in the Sunbears there will be a class called data frames, and in the class there will be the constructor method and these 5 methods. The first one is a string casting, or basically the string casting is this one, right? str. If you still remember it, sorry for my bad handwriting again. str, right? So which is to cast the object into a fancy string. The next one is the insertion. So data frame is a table. Insertion, this method will let you insert a new row to the object, to the data frame. Soft removal, it's basically to remove a row, but we will ask you to do just logically remove it, but not physically remove it. I will tell you later what is it, why do we need to do it. The next one is to process the object. So this is what this lecture about, right? I will ask you to process the object on this as a files. And then once you process it, I will also ask you to load it back, the object from the disk back into the memories so that the program can use it. So there will be 5 functions that I will ask you to do it. right? Honestly, these five methods are not the assignment last year. So I don't think UC statement can help you much on it. But they can help you saying that, oh, how chaotic it was. Right. So basically, yeah, I told you that there will be a class, namely data frame, there will be function, there will be methods. Oh, by the way, you don't need to write it from scratch because we can give you code template. So it will be, I hope that it is easier for you. And the important thing is that there are more than one possible solutions to make it complete, which means it is very easy to check whether you copy from your friends or not. It is very easy to check than last year, than the last semester programming. So if your code are very close, very similar, we may ask, I will use like the plagiarism platform called Moss, developed by Stanford, and compare all of your codes. If your code are very similar, I may need to ask you and talk with you guys. I mean, I understand that sometimes the code can be very similar, even though you are not copy. So that is why I will talk with you first. Then if you can demonstrate that, hey, I'm doing it by myself, then that's fine, right? There are some assumptions that you can make. For example, in the data frame in the table, they're only gonna be integer, float, and strings there. So they're not gonna be complex number, a map, a list in the data frame. But I didn't say that the data frame itself are not a list. Okay, I just said the value inside of it. The values inside of it can be only integer, float, and strings. But you can create a data frame using a list. There are now no null values for integers and real numbers in the data frame. The column name and values do not contain this straight line and the commas. If you're unsure, ask this on forum. Okay, start early. We give you 2 weeks plus to do it. It is harder than the previous assignment that I have assigned to you before, so please start early. And the lab 2 will give you next week, we'll give you a basic tours, but don't wait for the lab 2 because that is 1 week already, right? So I would suggest you look at the code and then at least implement something before you get into the lab 2. Okay. Teaching assistant will help you on forum. Some of them that I mean Ash. I believe that she's in the room, have gone to this assignment before in a different versions. And some of our TA have checked out those assignments before, so they are experienced. The point is that we will strictly not answer questions regarding the solo project through DM. If you want to ask questions about the solo project, you must not DM. Even though you DM, the TA will not respond to those questions. TA will say that, oh, ask this on forum instead. This is because this is not because we encourage you to use forum. I mean, that is my hidden agenda. But the real reason is that we want to just answer your question once, and we want to share your answer with all of your friends, so all your friends know the answer to the same questions, right? This to the same curiosities that you are wondering of as well, right? So every person have all the students in the class, they have the same information, right? So this semester will be very strict on the DMing, right? Or everything will be posted on forum. Every questions will be direct to the forum, unless it is very personal. Okay. So for quick suggestions, I suggest you first, when you get into the code, explore the constructor of the data frame class. You don't need to modify it now, but maybe you need to modify it later. Then you implement the insertion functionalities. Then you implement the sort removal functionalities. Then you modify the string. So we have already implemented the string casting for you, 90% of it. But there will be a part that you need to fix it as well. You need to modify it as well. And lastly, the export import functionalities. Oh, so it is now for persist and load functionalities. So in order to implement the persist and load functionalities, you need to design the file format to store data frame. And this is the hardest one. There's no fixed way to design the file format. This is what I'm going to say. There's no fixed way to design the file format. There are multiple ways, many ways. And I expect you all to not use the same ways. I mean, it gonna be hard. I mean, I don't think you all gonna use the same ways. I mean, because there are many ways, a lot of ways to do it. So you need to decide by yourself. And this definitely will be asked in the checkout. Why do you decide in this way? Okay. And the file should be the thing that it is possible for you to recover it back as data frame as well. Right. So what is step one? Data frame. So data frame is a table, right? So currently we use a list of tuples to represent the table. The question is, are there better representation for data frame? This is what the question you should ask. The insertions, this is the easiest functions, but you need to handle errors like various errors and the type errors as well. You may want to revisit this after step 3 because the step 3 is removal. And when you do removal, you need to modify insertions and the string casting. I asked you to do soft removal, which means you only need to have the way to mark the row as removed. You don't need to actually remove the row from the list. Okay? There are 2 ways that I suggest you here, but if you have the better way, feel free to do it. Right? String, you just need to modify it after you implement remove. And the 5th one is persistent load, in which I will ask Indy to give you it to give like a preview of this as an lab assignment next week, so that you have a glimpse of how to implement them. Okay. Any questions, comment, concerns about the solo project? I think I speak too fast. I spoke too fast. Any questions, comment, concerns? If not, that's it for the lectures. So yeah, see you next week on Tuesday for the lab. Well, not me gonna see you, but Indy and friends. And our teaching assistant will see you all in the lab next week. I will see you in the lecture next week, Wednesday. The lecture next week's Wednesday will be on site. So I will not open the Zoom like this. Okay, you need to participate on site next week. Okay. All right. Thank you so much and see you. Bye.